Hello students, welcome back to the third video of this playlist. So in this video, we will be solving the third question from the most recent past paper of Mechanics 1, which is October 2024 paper. So let's see what's the question number 3 from this paper is about. So basically, you can see on the screen question number 3. The concepts behind question number 3, it's from vectors that has been discussed in chapter number 3 of your Mechanics 1 textbook, that is vectors. Okay, so to be more specific, in this question we need to deal with position vectors, finding the magnitude of vectors, and at last in part C you will see we need to deal with finding position vectors, and yeah, finding position vectors. Okay, so let's get started with question number 3. Okay, so for vector questions, this is very repetitive. You can see I and J. I represents the horizontal vector, unit vector, and J represents the vertical, that is along the y-axis, that unit vector. Okay, a ship A is moving with constant velocity. Okay, fine. At 1 p.m., the position vector of A is 25I plus 10J kilometer. The initial position vector is given. At 3 p.m., the position vector of A is 55I plus 34J kilometer. This is the final position after 2 hours. At time t hours after 1 p.m., the position vector of A is what? RA kilometer. Okay, fine. So part A here asking to show that the position vector of A is what? 20 R of A, this is equals to 25 plus 15ti plus 10 plus 12tj. Okay, we need to find out the position vector of the ship A. Okay, so position vector, the formula for finding the position vector, that is R, right? R equals to what? R naught plus displacement. R naught is the initial position, and displacement is what? The velocity times t. Okay, so we need R of A. So right at first we need to find out the velocity, isn't it? So velocity is what? Displacement over what? Time. So displacement is what? Final position minus the initial position. So final position was 55I plus 34J. So 55I plus 34J minus the initial position was 25I plus 10J. So negative 25I negative 10J over what? The time. How much time? This is 3 minus 1, which is 2 hours. Okay, so 2. So 55 minus 25, this is what? Exactly 30. So 30 over 2, this is what? 15I. 34 minus 10, this is 24. So 24 over 2, this is what? Plus 12J kilometer per hour. Okay, so we got the velocity. Now we need to find out the position vector, that is R of A. This is what? R naught. Initial velocity, initial position vector of ship A was what? 25I plus 10J. So 25I plus 10J, which is R naught, plus velocity is 15I plus 12J times what? T. That much kilometers, since it's position. So R of A, this is combine the I components. So 25I plus 15tj, sorry, 15ti, 25 plus 15ti plus what? 10 plus 12 what? Tj. That much kilometer. So this is the position vector for ship A we found, and let's compare it with the given one. 25 plus 15ti plus 10 plus 12tj, and that's what exactly the part A has looked for. That's it. Okay, next is part B. So the speed of A is v meter per second. So part B asks here to find the value of v. So that means we need to find out the speed of particle of ship A, not particle. Okay, so the velocity is what? Velocity of A, we got v vector, this is what, 15i plus 12, what, 12j, isn't it? 15i plus 12j kilometer per hour, isn't it? So this is kilometer per hour. Okay, so we just need to find out the modulus, that is the magnitude of the vector, which is what, square root of 15 squared plus 12 squared, which is square root of 225 plus 144. So square root of 225 plus 144, that is what, 225 plus 144, this is 369. So square root of 369 is what? Square root of 369, this is basically 3 square root of 41 kilometer per hour. Okay, so we got the speed, that is the value of v. We got the value of v, this is what, 3 square root of 41 kilometer per hour. And that's what exactly part B of question number 3 has asked for. Okay, next is part C. Okay, before part C, they are saying a ship B is moving with constant velocity 20I minus 6j kilometer per hour. Ship B, this is another ship which is moving with constant velocity. The velocity is given as 20I minus 6j kilometer per hour. At 1 p.m., the position vector of B is 35I plus 551j kilometer. So initial position vector of ship B is what, 35I plus 51j kilometer. At 2:30 p.m., B passes through the point P. Okay. At 2:30 p.m., ship B, it's passing through the point B. Okay, fine. Now, part C is asking here to show that A also passes through P. Okay, that means we need to show that ship A is also will pass through the point P. Okay, in order to show that, definitely we need to know at first what's the position P is, right? So let's figure out the position vector of P at first. So for position vector of P, how can we find out? We know the initial position of ship B, right? We know its velocity. We know also the time, like the time at which the ship B is passing through the point P. So after 1 p.m., the time is 2:30 p.m. That means this is 1.5 an hour. So that means 1.5. The time is 1.5 hours. Okay. So for part C, we need to find out the position of point P, that is OP. This is what? Initial position of ship B is given as what? 20I sorry, this is the velocity, 35I plus 51j. So 35I plus what? 51j r naught plus what? Velocity. Velocity is given as what? Velocity vector is 20I minus 6j, 20I minus 6j, 20I minus 6j times what? 1.5. So 2:30 p.m. this is 1.5, that is 3 over 2. Okay, this will be the position vector of point P. So 20 times 1.5, this is what? 30. So 30 plus 35, this is 65I plus 1.5 times 6, this is basically negative 9. So 51 minus 9, that is basically what? 42j. So the position vector of point P is 65I plus what? 42j. Fine. Now we need to show that ship A also passes through point P. Okay. So if ship A passes through point P, that means the position vector that we found in part A of ship A, that will be equal to the position vector of point P, right? Because if ship A passes through point P, the position vector of point P will be the position vector of what? Ship A. Okay, so we will equate the I components. Okay, so when ship A passes through what? Passes through point P, in that case what it would be? Position vector of A will be equal to the position vector of point P. So equate the I components. What's the I component of ship A? Ship A has I component. This is basically 25 plus 15t. 25 plus 15t. Okay. 25 plus 15t. This is equal to the I component of point P. This is 65. So you will get what? 15t equal to 65 minus 25. This is just 40. So the value for t would be 40 over 15, which is 8 over 3. Okay, so we got the time t, that is 8 over 3, when the ship A will be at point P. Now we will put it in the j component, okay, or we will equate the j component of point P equal to the j component of ship A, okay, which is 10 plus 12t. So this is what? I component. We can consider this is I components, and now we will consider what? J components. Okay, so if you consider the j components, the j components are basically 10 plus 12t. 10 plus 12t would be equal to what? What's the j component of point P? This is 42, and we will see whether both are equal or not. Sorry, this is 12t. 10 plus 12t. Okay, so 12t equals to what? 42 minus 10, this is 32. So t equals to what? T equals to 32 over 12. So divide both top and bottom by 4, you will get 8 over 3. So as we have equated the I and j components for the position vector of point P and ship A, we got both the times equal. Hence, what we can say? Ship A passes through what? Point. What was the point? Point P. And that's what exactly part C of question number 3 of October 2024 Mechanics 1 paper has asked for. That's it.